This is a revision video for triple only on loudspeakers and microphones. And what loudspeakers do, loudspeakers convert current to sound, just like in the AirPods that you listen to music on. Microphones are the opposite. Microphones convert sound to current, and both require electromagnetism to work. So we're going to start off with loudspeakers. Loudspeakers rely on the motor effect. So we're starting off with current and we're ending up with motion, which is the motor effect. So the way we have a loudspeaker is we have a magnet like this. But around the middle pole, around the south pole, we have a solenoid. So we have an electromagnet. And that solenoid is connected to the electric circuit. And the type of current that comes in is alternating current. Alternating current goes into the solenoid. Into the solenoid it generates a small magnetic field. And that small magnetic field interacts with the magnetic field of the permanent magnets. And what that does, that generates a force. And that force is attached to a paper cone. That paper cone is attached to the solenoid, and that force moves the cone. Force moves the cone, and when the cone moves, that creates pressure changes, and pressure changes creates sound. And the reason why these pressure changes create sound, because this alternating current is constantly going in alternating directions, either up and down, left to right, depending on which way you want to look at it. So if the current's going in one direction, it might move the cone out. If the current's going in the opposite direction, it might make the cone go in. So either way, the cone is vibrating. The cone vibrates, creates pressure changes, which creates sound waves. And the frequency the cone vibrates, the cone vibration frequency is exactly the same as the alternating current frequency vibration. So if you're listening to music of 100 Hz and it's vibrating to 100 Hz, the cone is going to create a musical signal of 100 Hz. Now we revise loudspeakers using the motor effect. We're going to go on to microphones. And microphones are basically the opposite of a loudspeaker. Microphones utilize the generator effect. Remember, the generator effect induces the potential difference, and the potential difference, if it's part of a whole circuit, induces current. It's still the same setup of magnets. We've got a three-pronged magnet, north, south, north, and that middle coil, that middle pole, has got a solenoid wrapped around it, again attached to a circuit. But this time, instead of it having a cone attached to it, it has a diaphragm, which could be a thin piece of plastic or a thin piece of paper. And the diaphragm is very similar to the eardrum, like in the ear. So what happens, it basically works in reverse. Loudspeakers ended up with sound, creating alternating current. A microphone is the opposite way around. We start off with sound and we're going to end up creating alternating current. So what happened, the sound vibrates, the sound vibrations cause the diaphragm to vibrate. And when the diaphragm vibrates, it's attached to the solenoid, so it moves that solenoid over the pole. And because that coil's moving over the pole, it induces a potential difference. So third step, vibrates solenoid over the pole, and that induces potential difference. And because this is part of a complete circuit, let's put the ammeter in to make it a complete circuit, because it induces a potential difference, that generates a current. And because it's vibrating backwards and forwards, that means it's creating current backwards and forwards, and current backwards and forwards is alternating. So the current it generates is AC current. So let's say we're singing into the microphone with 100 Hertz. That's the frequency of someone's singing voice, let's say, arbitrarily. We're singing into it at 100 Hertz. The alternating current that comes out is alternating current of 100 Hertz. So let's just recap. Loudspeakers use the motor effect. We've got alternating current into a solenoid that's around a pole. The current in creates a small magnetic field which interacts with the magnetic fields of the permanent magnets. This creates a force which moves the cone. This cone vibrates backwards and forwards depending on the direction of the current, and as it's alternating, it makes it vibrate. This creates pressure changes, and these pressure changes in effect make the sound. Microphones are the opposite way around. Microphones utilize the generator effect. So the sound vibrations come in, and that vibrates the diaphragm. That diaphragm is attached to the solenoid, which vibrates over the south pole. And because it's moving, because it's cutting the magnetic field lines, it induces a potential difference. And because this is part of a complete circuit, that generates a current, and that current is at the same frequency as the input sound.